So a couple of months ago, when I was wasting my life in front of YouTube watching cat videos, I came across a bunch of special ones, where they essentially take the cat's meows and pitch shift them in such a way so that it almost sounded like they're singing a song. So I thought that was pretty interesting, but the weird part was that it was also strangely addicting to watch. But because there's not a lot of these things around YouTube, I can't just binge on 5 hours of these at a time like I normally do with other videos. I was about to give up, but like with drugs, addiction got the hold of me and I decided to put myself through this horrible dumpster fire. My ultimate goal after getting addicted to these cat videos wasn't to snort more of it, but rather I wanted the cats to sing some of my favorite songs. So naturally, there are two ways I can accomplish this. The first way is to ask the creator and pay them to make one for you, which we can already throw out the window because, well, first I'm broke, and second I have the interpersonal skill of a tarp. And the second way is to create it myself, which is also a bit of a problem because I have no artistic or musical talents whatsoever, so I'll have to resort to the one thing that I'm half decent at and not absolutely garbage with, which is computer programming. Alright, so let's break down the problem a bit before we go absolutely insane with it. So what the people are essentially doing in the videos, or what I assume they do, is they just simplify the original music down to the bare bone notes where you can just about make up the Rickroll theme and not mistake it for the Baby Shark theme or something else. Then they take those notes and just use those as a reference for how much the cat sound should be pitch shifted. And at last just slap them all together and get a beautiful cat video starring a cat as Rick Astley. Alright, so that doesn't seem so complicated. In fact, there's already loads of software out there that already do these types of things. So why do I not use any of those software? Well, first, it's because that would make for a very boring video, and second, and more importantly, is that those software works based on something called Fast Fourier Transform, or FFT for short. Now for those of you who don't know, FFT is a collection of funny looking squiggly lines that can detect the frequency presence in a sequence. And this works well for a lot of things, but when it comes to music, unless your music is literally a fire alarm, which I'm not going to judge if it is, there's going to be a lot of noise and notes that aren't important to the music. And when you ultimately give a music sheet generated from FFT to the cats to sing, it will sound like absolute dog shit. Instead, the way we're going to be doing it is with something called deep learning. Wow, he's such a controversial crackhead. Yeah, I know, right? I won't be explaining the whole process of what it is and how it works here because that will literally turn this video into an hour-long lecture. But if I have to explain it in a nutshell, it's essentially where you throw massive amounts of data at a computer and have it learn patterns and features from those data. So that ultimately when you give the computer new data it has never seen before, it would still be able to give you some useful information on those data. Now, why deep learning? Well, first it's because I think it'd be cool to watch an AI try to do this, and second because I think it's gonna give me a much better result. With deep learning, you're essentially trying to find patterns in the music and trying to classify them to a certain note or a certain chord, which means that it can learn to ignore noises, unimportant chords, and other stuff that you don't want to include in your final music sheet if you give it enough data and enough love. So that doesn't sound too bad. I'm sure this is gonna be an absolute delight to make this project. I'm gonna learn so much. Alright, first thing we have to do is get our data. This shouldn't be too hard because there's already this website that has a whole collection of Bach musics in MIDI format. That's great because they act as the output in our dataset, meaning we essentially got half our dataset just from a website. What's even better is that Bach's music isn't copyrighted, meaning I can use it without getting fricked over by you prick. Anyways, now that we have the MIDI files, we can use that to synthesize the audio files of what those MIDI should sound like through the magic of Timidity++. Thank you for letting me use your software for this horrible project. Then I turn the MIDIs into CSVs so that my program can actually parse the thing and simplify it down so that it's even easier to read. But now we have a problem. Remember how I said that deep learning needs a crap load of data to work well? Well, I'm sorry to inform, but I only got about 30 MIDI files from that website, meaning only 30 data points, which is not enough. Okay, that's fine, I guess we'll just improvise. Each music piece is about 3 to 5 minutes long, meaning that if we split them into little pieces of say 3 seconds, we'll get about 2,500 data points. Still not enough. Okay, fine, what if we throw in some drum loops so it mimics real music? That raises it to about 7,500 data points, which is still pathetic. Like for context, the MNS dataset, which is like a deep learning dataset that teaches AI to recognize images of handwritten numbers, has over 70,000 data points. But whatever, I guess we'll just have to deal with it. Ignoring that caveat, I splitted the audio files into little sections as well, but little did I know, that's when everything started to fall apart. Alright, time to make the neural network, which is going to handle all that transcription for us. We're going to be using something called long short-term memory, or LSTM. Now, LSTM is a type of recurrent neural network which is apparently really good at dealing with sequential data, things like audio or text or whatever. I'll link a blog about it in the description if you want to read up about that. It explains very well why it's so good at its job. So I loaded in our good old Keras and TensorFlow and wrote some code to parse in the data which I generated earlier, which took way freaking longer than I initially thought it would. This kind of raised a red flag in me, but I ignored it and created this amazing, just fantastic neural network. Don't you just find so much pleasure looking at it? Yeah, not really. And when the time came to train it, I was greeted with more errors than I can count and boxes redder than the communist sun. So after fixing my awful code and reinstalling countless libraries, dependencies, and a bunch of fancy vocabulary, I finally managed to get the thing to train properly. So after like a day of training, I decided to take a look at the training loss of the network, which just measures how well the thing is performing. Usually a lower number means a better performance, and they should look something like this for a well-trained AI model. However, when I checked my training loss, I was greeted with this. No, that can't be right. You know what, let's check the output.
I've created a 3-month...
What the fuck? The loss was all over the place and my confidence in this neural network dropped to rock bottom when I saw it. But before I go and buy a course on machine learning because of this one graph that definitely did not destroy my self-esteem, I wanted to at least try something to improve the look of this awful graph. So I tried changing the function that determines how well the neural network is performing, aka loss, still a giant mess. I tried changing the network architecture to a bidirectional one, still a giant mess. I even tried changing the training algorithm to, this one, but apparently TensorFlow doesn't support it, so I guess that didn't work. I tried to rewrite it, I tried to calm it down, and I even tried counseling, but there was still no change to that demonic graph. At this point, I'm getting desperate, and at one point in a futile attempt to save the thing, I thought to myself, wouldn't it be funny if all along it was my training data that was bad, and I was just training on bad and broken data this entire time, meaning that I wasted over like 20 hours of work trying to fix the thing? Like that's ever gonna happen. Wait. So yeah, who knew that programming at 3 AM along with sleep deprivation can have such a devastating effect? Alright, cool, let's just start over then. It's not like we just lost 3 weeks of work or something. This time I want to be a bit more modest, meaning that instead of stealing other people's hard work for my training data, I'm gonna generate my own data. Well, how do you do that? You ask. Well, my friend, let me walk you through my ingenious process of procedurally generating training data for a neural network. First, we got this thing called a raw MIDI generator, which, as the name implies, generates raw MIDI files. I'll put up a rough sketch of the underlying algorithm if you're interested for some reason. It's not that hard to understand. You got some normal distributions and stuff, you pick no space off those things, you combine them together, generate some space based off some threshold or whatever, and bam, there you go, you got some rudimentary MIDI files. You take those raw MIDI files and turn them into a CSV spreadsheet through this recursive algorithm that I definitely didn't spend 3 hours on instead of doing it iteratively, which could have probably spared me like an hour of misery. Convert those CSV files into MIDI files through MIDI CSV, or sorry, no, I mean CSV MIDI, synthesize them with timidity, actually synchronize them, trim them, and save them, and there you go, you just learned how to generate data for a neural network. But why? Why bother doing all those when you could have just synchronized the last one? Oh, you're just being the nosiest little schnot today, aren't you? I didn't go through all this just to prove that I can in fact do programming. The reason why I bothered to rewrite the whole project in the first place is because the original one was short of nothing but being a complete dumpster fire. Saying that is an understatement, and lacking of a better description, one famous man has once described something of equal quality
like a big pile of manure stuffed with firecrackers in a napalm factory. They never cease to amaze me.
So yeah, hopefully that should shine a light on just how bad and unfixable my original code was. Not to mention there was literally no comments anywhere besides for this one to-do. So after getting actual high quality synchronized data, I started working on a proper bidirectional LSTM network. Printed out some real debug messages this time, and got it to train pretty effortlessly with a loss called binary cross entropy and an optimizer called atom. And because no one cares about these things anyways, I won't explain what they are or what they do. If you don't like that, you can bully me in the comments and I'll be sure to look at them and cry a little bit. And after just like 10 minutes of training, the loss was already getting unnaturally small, which made me feel unnaturally anxious. I checked the loss graph, and long and behold, we finally have something close to normality for once. Ignore the green line. The green line is a special child that is not like any other losses. He likes to be special in his own ways. Now, I was careful not to be too excited, because these graphs can trick you into thinking that the network is performing better than it actually is. AIs can be really smart and break the system. For example, the AI might just be generating all zeros to trick the monkey brains into thinking that it's performing better than it actually is. So the only real way to confirm its performance is to actually test it on some data. This is the day I dreaded. What if all that work didn't work? What if all those time spent bashing my head into my keyboard was to not prevail? I had to do it nonetheless. It was what this project all led to. So I prepared two music pieces for the AI to try out. The first one is a simple piano piece, which I'm expecting the AI to do decently on because after all, it was trained on piano notes. And here are the results. Okay, maybe that cat dub wasn't such a great idea after all. It wasn't able to pick up some of the higher pitched notes, and it certainly isn't the most accurate in the world, but it does pick up the important notes somewhat okay-ish. There's definitely a lot of room for improvements here, but having the network just spit that out based off of unfiltered raw audio and only one cycle of training, to me that is a huge success. I actually spotted another major issue with the algorithm while I was recording the audio for this video, and that is that the output that the AI gave me was somewhat chaotic. Especially in the middle part where the notes are changing fast, the AI kind of panics and results in this awful mash of meows. But hey, it's cat music. Not good ones, but it's cat music after all. Unfortunately, my data got corrupted after hearing the results and stuff, so I wasn't able to train the thing based off of the same data for more than just one cycle. Alright, the next music piece was actually what surprised me. This is more what you'd find if you just googled pop music, because there's a lot of complex melodies, human vocals, percussions, and all that stuff that I did not train the AI to recognize. So let's take a listen to the output and listen to the AI struggle.
So are you gonna die today? Make it out alive. You gotta conquer the monster in your head, and then you'll fly, fly, Phoenix fly. So are you gonna die today? Make it out alive. You gotta conquer the monster in your head, and then you'll fly, fly, Phoenix fly. So are you gonna die today? Make it out alive.
Yeah, so it definitely didn't do so hot on that one. There were a lot of seemingly just random notes everywhere. It couldn't synchronize notes with the music correctly, and the whole thing was just pretty much a mess. Now with this logic, you might be tempted to call the last attempt with the piano music a mess too, and you're right, it is. Just slightly less so. But even then, you can occasionally hear from time to time that it transcribed a part of the music correctly. Like, take a listen when I tried to transcribe the part where it goes, "Monster in your head." It's still not nearly as perfect if I had paid a human to do this for me, but still somehow it had managed to sort of do it. So what's to learn from all this? First off, neural networks are stupidly good at doing stuff, or just even one round of training on randomly generated data can yield this type of results. Second off, processing raw audio data probably isn't the smartest idea if you want more accurate classifications. Usually people exploit audio spectrograms, things like mil spectrograms, or even FFT so that they can more efficiently process audio during audio analysis jobs. And these aren't simple jobs either. People use these in all sorts of things, ranging from speech synthesis to audio analysis. Third off, getting a proper cat dub that is clean over music is way harder than I initially thought it would be. So what started as a decent MIDI transcription might just end up as a pile of unintelligible meows mashed together in a freaking blender. I can go on and on about this thing, but the video's already getting way too long, and judging by the fact that you're still here, you must have a pretty bad taste in YouTube content. But I appreciate it. So yeah, there you go, an AI that can make cats sing songs. Sort of. I do have plans for a second version of this that should work way better than this nightmare, and let me know in the comments if you want to see that video or not. The code will be in the GitHub, and I'll link it in the description if you want to check it out for some reason. Thank you for watching to the end. I hope you enjoyed this fever dream of a video. It's been fun, and goodbye.